There we go. All right. So finally into some more interesting material, or what I think is more interesting material. Safety's fun and important, but this is definitely the more meat and potatoes of what we'd like to talk about. So 190102A, frame and suspension fundamentals. Why are we going to talk about all of this kind of stuff? Well, we need to know what a suspension does, what the frame does, what they're meant to do, and what they're not meant to do. And I'm guessing for a lot of you who've worked, if you've worked on-road equipment, you've probably done quite a bit of work with suspensions for sure, and quite possibly with frame. Being in the heavy-duty industry, we tend to put our equipment through its trials, and sometimes it goes beyond its limits, as we'll talk about. So the 4 objectives of this ILM, we're going to the functions of the frame. Then we're going to talk about the different types, what the different components in the frame are, and where all their applications fall into place, because there's some specific applications for each type of design. And then the functions of the suspension and the operating system, so operating principles of the suspension. So the frame is very, very important. It has a whole number of functions that we quite rely on, and essentially, as most of us know, it's the backbone that we build everything on. So it's the piece that everything is attached to on our tractors. Not only is it what all of the driving components, right? Sleeper, cab, hood, engine, the wheels, and all of the fuel and all of the lines and associated components, suspension attached to. But we also need the frame strong enough to be able to support the load. All of our vehicles are designed not just to carry grandma and grandpa down to the grocery store, okay? We're actually going to be hauling groceries. All of them are going to be doing work of some kind or another. So they need to be able to withstand that load. It also, if you've ever seen a U-Haul body job driving down the road, seen the frame twisting and weaving as it goes down the excellent Alberta highways that we have around here, it needs to be able to handle the shock and torsional loads that it's going to be experiencing while the vehicle's in operation. When it is under these torsional loads, you can have the point where all of the force is concentrated. So for instance, on these types of vehicles, you're going to see all of these points here are the typical points where you're going to end up with frame sag. So has anybody seen pickup trucks where you have right inside of here, you know, the cab and the box of the truck end up coming a little bit closer together, right? Rather than having a space in between the two like that, they end up sort of coming a bit closer together, where the frame is sagging in the middle there, okay? Common spot, common problem, and it's from fatigue and overloading. So now in your dump box, you could have the same problem right here, okay? Right at the point of pivot. And in your tractor trailer, it'll just move around. Depending on application is where it's going to be applied, your maximum bending moment.
Yeah, my Texas bed, it's right behind the winch, just right on the right below the walking deck every single time.
Oh yeah. Yeah, it's wherever they apply that large force is going to be applied, right? Like a winch truck will have a certain area where it's going to be, dump trucks are going to be different. Every place will have a place where all of the force ends up being concentrated. Pretty basic so far, okay? Now we'll start getting into how these things are built. So that's what the frame needs to do, okay? It needs to have a place where we can attach everything. Suspension, sleeper, cab, all the stuff for driving the unit around and carrying loads. It needs to be able to hold the load, and then it needs to be able to withstand driving around on these lovely highways. So this type of frame, if you've ever seen the guts of a truck, this is pretty typical for all types of tractors on the highway. if you stripped a lot of them down, you'd have a hard time telling the difference between any one of the major brands out there, right? They all look very similar for tractors. So this one's particular ones from Freightliner. Yet again, if you took any truck down to the bare frame like this, you'd have a fairly hard time just looking at it telling the difference, unless you were really, really familiar with them. So this type's called a ladder kind of frame. Hopefully you can see why it is called a ladder, because it sort of looks like a ladder laying down here. That's why they call it a ladder frame. So this is a typical highboy trailer frame. So all kinds of trailers will just have different variations on this based on what they are. And for most of us out there, we've probably seen all different kinds of trailers, okay? You might have a trailer that'll have I-beams like this, but instead of a deck being up high, the suspension will sit in between. The cross members will be lesser, but quite a bit larger. So you'll have fewer of them, but they'll be quite a bit bigger. Might be closer down to the ground. And then you're gonna have a large container on here or a tank, something to that effect, okay? Chip trailer, the body itself might actually be the frame, okay? You could have part of the container itself being part of the frame. In dry bulkers and in some tankers, that's the case, where the actual vessel is part of the vehicle frame as well. For us, for right now, we're just going to talk about pretty basic, the way this ladder frame is built here. Or, okay, you can see the two main frame rails with cross members going in between.
Quick question.
Absolutely, yeah.
When you have a tank trailer, for example, that is the tank is being a major structural component, how does that affect your maximum bending moment?
So there is going to be an ILM where we'll look at some pictures of tanks, and I'll show you essentially it's what these maximum bending moments are. It's just to be aware a location of where you could find possible bends and damage, okay? And so I'll show you where on a tanker those would be. And commonly what I would see is that's just where you would end up having cracks end up appearing. And for any of you who've done anything with fuel, you'll know that you have to get your tanks inspected. And so that would be part of that. They would most of the time find any of this damage starting to happen at the maximum bending moments on the trailer. So essentially, depending on, just like a tractor, depending on application, it's going to depend on where that point of concentration of force is. Does that answer your question?
Yep.
All right. And we're going to look at an ILM that has a bunch of different types of trailers and stuff. And I have pictures of all different kinds of trailers as well that we'll take a look at. Another type of suspension you've probably seen, and yet again, this is just one. So what they're showing, a trailer body, they're showing a van body here. Most likely it looks like a van with two barn doors here. These frame rails are essentially going to run the length, but these sliders won't be there. So where you see these holes all along the frame here, they'll stop at a certain point. But this portion and this portion will continue the entire length of that van, and that'll be part of the frame. And then at the front, your fifth wheel pin would end up being structurally inside and coming out of the body itself. So, and yeah, also so this trailer, this sub assembly here will slide back and forth. Why would you want it to slide back and forth?
For weight purposes.
Yeah, exactly. It's you can adjust where your weight is, because for any of you who've operated anything, you know there's a specific amount of weight you're allowed to have on each axle, and depending on what you're carrying, you can concentrate that weight, and it can be concentrated too much in a way that your vehicle and your load ultimately becomes too much weight pressure on the road. So that is exactly why that is like that. And yet again, this is just one simple picture of a sliding trailer. There's all different types of variations of sliding trailers and sliding suspensions for all different types of applications as well. So there's decks, and there's trailers for hauling pipe, and there's trailers for hauling sea cans, and there's all trailers for hauling equipment, drop decks and low boys and all different kinds. There's flip backs and beaver tails, and we'll talk about some of these too. So how do we build frames? So the different ways that frames are constructed. Typically, we're going to have a selection of 3 types of frame rails: channel, box, and I-beam. Okay, we can sort of see why they are named their specific names. So the channel, often called C-channel, typically this is what you're going to see on tractors. Okay, you're going to have 2 C-channels running the length, and then different types of frame rails in between. Box and I-beam are typically what we find in different types of trailer construction. Regardless of how the entire frame is, like even if the van body is part of the frame itself, typically you'll find an I-beam or a box beam hidden inside of the deck somehow, and that will ultimately be what incorporates the body into the frame itself as well. There are some instances where tankers, though, it is literally just the tank, and then you have different assemblies built at the front with box and different assemblies at the rear with I-beams to attach the suspension, any other fifth wheels, any components like that too. So what do we call the different parts? This is going to become important. The web of your beam, this large portion here, and then we're going to talk about flanges. Very important to differentiate between flanges, where the X's are, and the web, where the squiggles are. Very, very important, okay?
Is the only difference that it has an outside edge?
No. And the one where it would be difficult to talk about is the box. What it is. So on a channel, it's easy to tell. The web is always going to be the section between here, between the 2 bent portions, okay? So this is always a flange right there, and this is always the flange, okay? Always.
Upper and lower, is that the key word there?
I mean, it's only upper or lower if it's that way. If I took this piece and turned it this way, then
Still the web.
This one would be here, and this one would be here, but they're still flanges, and this is still the web. Okay. When it comes to a box, it's a little bit difficult to tell, but typically your box isn't going to be a perfect square. It's going to look like a rectangle like this. And it has to do with orientation as well. As long as this is the side that is up and down, this is the web. And almost always the web is going to be thicker than the flange is going to be wide. Does that make sense?
Yeah, that's what I meant. Like say if that box was laying down on the web, or I guess not the web anymore if it was laying down.
Yeah, if it was, and that would be strange. Like I've never seen,
Oh yeah, that'd definitely be strange.
Yeah, I've never seen a trailer that would have been put together with a box put like that. They're always like this. Can anyone guess why? Because once I start talking about I-beams, I'll tell you why, but does anyone have an idea?
Once you go over a bump, it would bend like tissue paper if it was laying on its flat.
It sure would. Yep. It's because the way beams are made, the strength against bending is in the web. So believe it or not, This part here on the I-beam is what stops it from bending this way, okay? These flanges would bend just like tissue paper, just like what whoever said that said, or I agree completely. If this were laying on its side, this would bend very easily. As soon as you would go over a bump, it would bend up or down or however. And so that's why the web is always the thickest part, and it's always going to be the part that is vertical up and down. Yet again, a box like that, I've never seen it. Is there somewhere where it could be? Absolutely. I mean, I shouldn't ever say always, but from what I've seen, you wouldn't put it like that, and it's because that you'd have to structurally strengthen the frame some other way then to resist that bending anyway. And this technology that they're using here, we've been building beams like this a long time, and we know that they're strong that way. So they wouldn't want to go trying to reinvent the wheel in a sense, I guess. Okay. So does that help with everybody determining between the web and the flange? Because it's very, very important that you know the difference.
You bet.
Perfect. The other important thing to keep in mind always when you're talking about frame is going to be thickness of material. So that's the thickness of the material here, thickness of material here, or thickness of material here, okay? You won't often find a beam where you will have, for instance, really thick I-beam and then really thin flanges, okay? You won't have very thick web like this and then thin flanges. Typically, it's all made out of the same thickness of material this way, okay, cross-section wise. Now, what you can see, for instance, is an I-beam where you might have a web that's 3 feet up and down, okay? But your flanges aren't going to be 3 feet across. Okay, does that make sense? Hopefully.
Yep.
Perfect. If you guys like to, if all of you like, however you like to do it, I don't know, we're trying to find out new things. Is while I'm talking, if you come up with questions and you want to send them in a text later or an email, that might work too. I don't know, just depends on how your communication is. It's typically, it seems I hear from a certain few people, so I don't know if some of you don't have anything to say or anything like that, so it's a little bit different than the class. But any questions at any time, however you need to ask them, please write them down and then just shoot me an email later. So the 3 things to know about frame rail terminology. We need to know the material thickness, the different types, the upper and lower flanges, and the web, okay? And flanges just in general. We need to be able to distinguish between the flanges and the web. So cross members. Cross members are connected to the webs, not the flanges, okay? Very important, and there's a reason why. We will talk about that. We will talk about it. They essentially are what keep everything stiff, right? They contribute to frame strength and rigidity, as well as allowing the frame to bend a certain amount, but then return to its original shape. So frame rails will be beams like this. Cross members will be beams as well, just smaller, and they will go through the web of the trailer like that, okay? That's how it will be designed in this highboy suspension here. You'll have large channels here, smaller ones going through the web, if you can see that, how it's built. They're going through the web. And they do rot out and rust out, and then you have to cut them out, and you can section off pieces of the trailer and slice that.
We just did that to a trailer. Completely gutted it and changed out like 4 or 5 frame rails, and it was a
Nice.
Yeah, I did that too. A couple of aluminum cross members on a chip trailer. They were rotted out.
Mm-hmm.
Yeah, you just have to pull all the decking off and then cut it all. And then he wanted to get it sandblasted after, and then there was a bunch of more holes in it. I knew he should have sandblasted it first, but I don't know.
Yeah, if you're gonna sandblast, go right away. You'll find everything then, right? If you want to spend the money anyhow. So otherwise you're gonna be finding things as you go, and the bill will just be a surprise and getting bigger and bigger and bigger, right? So but yeah, so common, like you've already seen some of that. That's very common damage that's going to happen is cross members are going to rot out. They're going to wear out, bend, break. Okay. And that'll be how you're repairing them, is sectioning things out, taking the deck off, getting everything out of the way. Or in the case of a chip trailer, you can't get anything out of the way. So working in the tight confined areas most of the time.
Yep.
Yeah. So the gussets are these little triangular pieces here. They don't show you a very good picture of them. Number 5, I'm going to zoom in on it here. This is sort of one thing I like about this. Like I can zoom in and I can color on here and I can say this triangular piece is what they are referring to as a gusset. Okay. You'll have one on the top here. There's another one up here. There's one here. Okay, those are also going to be the gussets. When they're pointing at number 4 and calling it the channel, it's because there's a box here. That is the channel they're talking about. So we have those gussets for a very simple reason. Who remembers what is the strongest shape in geometry?
Triangle.
Oh man, that was so quick. I have a chance to think. So with that, knowing that, why do you think we have gussets?
Adds.
I don't know if when I'm welding something, if I'm worried it's not strong enough, I'll just put a gusset somewhere.
You'll just put a gusset somewhere.
They're just handy. You just build a triangle, put a gusset, and that's good.
I mean, I guess if it works, yeah, it works. So, but yeah, you're absolutely right. Building triangles is a way to reinforce things, okay? So we have our channels here. We have frame rails going across now. What's going to end up happening is because you have such a small little angle here, the frame is going to want to move forwards and backwards, and you're going to end up with a lot of weaving, okay? So I know frame is...
I'm not sure if there's anybody else, but I can't see anything you're drawing right now.
Oh,
Can't see
okay.
anything either, just a white screen.
Just a white screen. Okay, let me figure that out. Thanks for telling me. How's that? Can you see my really nice drawing now?
Yep.
Yes.
Excellent. Okay. So like I'll sort of draw over it again. Channels, okay, frame rails right there, however kind, and then cross members coming across. So what you end up having is a weak spot here where the frame, these two channels can move independently from each other. And you might get one where it starts sticking out more up here. And then it's going to look like that kind of thing, okay? You're going to have these start all going at an angle rather than being nice and straight. And that's going to be bad, okay? When things start coming apart like that. So what do? We add these triangular pieces called gussets to all the frame rails. And just like he said, that stops them from being able to flex, adds rigidity to them, okay? Let's see if I can do this properly now. Stop that. Start this. Open this one. There we go. We're back to the ILM now?
Yep.
Excellent. All right. So that is gussets and why we have them. So they prevent what is called weaving, frame weaving. Can you guys see my mouse as I move it around?
Yeah.
Oh, awesome. Okay. So yeah, gussets provide resistance to frame weaving, which is what you'll get when you have the frame rails moving forwards and backwards from each other. What does frame strength depend on? Two different things, two very important things. The type of material and the size and shape of the frame rail. Seems pretty straightforward, right? How strong is something? Well, it depends on what it's made of and how it's made, right? The design. So different types of materials are going to have different yield strengths. I believe Clint went over this a little bit, talking about different types of alloys and, right? Different types of steel, aluminum, what its yield strength is and what that means. So how much force can we put into it before it's permanently deformed, before we bent it beyond all recognition and it won't come back anymore?
Elasticity.
Elasticity, yeah, that's one force. Yeah. So once you go beyond its elastic limit, you will hit with its yield strength. Then it will bend permanently. So there's a very wordy sentence. Steel frames. I'm sure all of us have seen steel frames nowadays. They used to be super common in light and medium duty applications. They're becoming more and more common in light duty stuff, and even some medium duty applications now. And in heavy duty, steel has just been there forever, right? I mean, that's what we see all the time. What's becoming more popular is aluminum. Who is seeing aluminum frames out there? And I don't even mean on your pickup truck. I mean like decks and vans and all different kinds of stuff are coming in aluminum frames and stuff too. So
I haven't seen one yet, but
they are lots out there. And I mean, depending on application, there's nothing wrong with it. If you know you're hauling something that's very light, ultimately, right? Hauling a whole deck full of pillows is a lot different than filling a gravel trailer full of gravel if you thought about the same size container, right? So it depends on what your application is. And there's nothing wrong with aluminum. There is one clear downside to it. Does anyone know what that is?
Melting point.
yeah, I was gonna say
Yeah, that definitely does come into play, especially for us. We like to go grab torches and stuff like that. And welding is another one that comes to mind with that. I find the biggest problem with aluminum frames was the corrosion.
Oxidation.
Yeah, the oxidation. That was what the biggest problem is. Because no matter how much they could make aluminum, they still had to have a lot of steel. And when you start putting aluminum and steel next to each other, you're making a battery essentially, and you're going to get that oxidation of the aluminum.
Hence why I had to change some aluminum cross members a few weeks ago.
Yeah, and you said it was in a chip trailer, right?
Going through a steel frame.
Yeah, and so even that, in that situation too, not only is application corrosive, right? But in the area it's in, it's hauling chips. Like the liquid that it's constantly exposed to will accelerate that oxidation. So, sorry, I have a fly flying around in here. That's really annoying. There, I think I got it. Okay, anyhow. So what a frame is made of. That's going to be the first basic thing to determine strength, okay? Steel, you can get stronger steel frames than you can get aluminum ones, but depending on application, as long as it's sized right, you're okay. Would I take an aluminum frame highboy out to go pick up a giant crawler or something? No. Okay. Size and shape. This is the other determining factor. So the design. If you got a thick enough piece of aluminum that was big enough, you could haul anything. But by that point, you're using such a large piece of aluminum that you're not saving any weight either. So the advantages of it have gone away. So how you're designing something and how much material goes into it is going to be a large determining factor on its strength. So what determines our section modulus or the strength? Three main components. So the thickness of the web, okay? The thickness or the width of the flange, and then the thickness of the material. That's going to determine what they call section modulus, and that's what will determine the ultimate strength that this frame can handle. Has anybody ever had to do any of these? Reinforce a frame or plate it?
Absolutely.
Absolutely.
Yeah.
Yeah. It's
Oh, really? I've always just cut. If I found something like that, I'd probably just cut it out and put a new one.
yeah, and that's perfectly acceptable as well, as long as you're doing it properly. Typically, if you're sectioning a frame out and welding components in, you'd also fish plate it. Typically, is what I've done in the past. Yet again, though, I've put together. The only thing I haven't personally done is put a frame together like this. Okay. I've reinforced frames with all of these other methods, as well as cutting it and sectioning it before too. Working with a welder, of course, is where I was working at a shop that did collision repair, and so we did lots of bending and repairing of frames like that.
I think I've fish plated.
Mm-hmm. This is a very common, if you start getting cracks in frames, to fish plate it, and you can bolt it on or weld it on. We don't talk about it very much specifically in these ILMs. There's a few things I'll mention about it, but there isn't too much in depth about it because you need a welder to be welding the frame together. If you're going to be sectioning it out and weld it, it should be an actual welder doing it. If you're there to make sure that they put all the other components on correctly, right, like the suspension, brake system, all of that, then perfect. And I mean, sometimes when you're working with someone, you can't help but learn what they do and vice versa, right? So it ends up being the welder can help you out with brakes, and you can cut some things apart and tack things in places as well, right? So that resisting bending moment. The higher maximum bending moment is the point where it's concentrated. So that's where the maximum bending moment is. And the resisting bending moment is what talks about the overall strength of the frame. So if I have a high resisting bending moment, I have a high strength frame. My maximum bending moment is where the point of concentration is on the frame. Make sense? Lots of good words. All right. Any questions about that objective so far? Oh, sorry, went to the wrong one. Those first two, how frames are built, what they do, what they're made of, all that good stuff. Oh. Like I said, if you do want to say anything at any point, just unmute yourself and say it. You interrupt me, please, because I'd rather you ask the question than wonder something. Okay.
Is there a reason why it's highlighted yellow?
I highlight these things because I like to talk about them. These are notes for me and maybe even notes for you if you'd like to. So you don't have to highlight anything, but if you choose to highlight things, the things I highlight might be important. So I like to go through the ILMs with you and look at it like this during my presentations, because this is what your guys are looking at too and reading. And sometimes there's things in this book that need to be talked about and explained a bit better. There's lots and lots of words in here, and you can distill it down a little bit. So that's why I like to look at this. All right, let's get through these last two objectives. So talked about frame, what it does, what it's made of, strength, all this stuff. Now, suspension, one of the major things that is attached to the frame is the suspension, okay? And we're just talking about what holds the actual axles in, okay? So secures the axles to the frame while maintaining alignment. So they hold everything in place, right? Like our wheels are held in place and they maintain alignment. We'll talk about that a little bit, and tire wear. They support the weight of the vehicle and its cargo, also while maintaining lateral stability. So we'll talk about the difference between alignment and lateral stability a bit. Cushion shock loads when we're driving, and allow the axle to move up and down relative to the frame so the tires follow the contour of the road. So these last two are quite intermingled. So attaching everything to everything. We need to attach the axles to the frame, right? So our axle right here, this is where we're going to end up having wheels attached to through our hubs and bearings and all that good stuff. We need a way to attach it to the frame. So we're going to have different types of brackets and hangers right there, different types of brackets, hangers, shackles, all kinds of stuff. Where's my pen? Okay, different types of the brackets, shackles, pins and bushings, rubber bushings inside of here. You're gonna have shock absorbers that have little rubber bushings in here, all different kind of good stuff like that. That's how we attach them to the axle, attach the axle to the frame so that it doesn't go anywhere, right? If this was a drive axle, especially if it's not attached to the frame, it'll drive away and the vehicle will be left sitting there, right? We've probably all seen a picture on the internet of something funny like that. The other function they need to do while being attached to the frame, we need to maintain alignment, okay? So alignment has a significant effect on vehicle handling and the life of tires. Who's been doing alignments and measuring alignments?
We don't have an alignment machine, but we do it with it.
You actually have an alignment machine?
No, we don't. We just use a tape measure.
Okay. Yeah, and that's perfectly acceptable in the heavy duty industry. The tolerances for our applications using a tape measure is perfectly acceptable. So why is alignment important? Because if this wheel and axle assembly starts wanting to go sideways here, like this, which direction is the vehicle going to want to drive in?
To the right, to the right.
Not straight ahead anymore. So alignment has significant effect on handling, which is a safety concern, okay? Because we're out there, everyone's driving out there on the roads every day. We don't need this vehicle driving being out of control, especially steer axle alignment's quite important. Also, what service operators, service managers, fleet managers, number crunchers are all worried about is tire wear and alignment problems and suspension wear. So worn suspension components will chew up tires so quickly. I think there is a few of you who worked at tire shops. Am I correct?
Yeah.
Yeah, okay. I know there's one of you for sure told me about it, but I think there's a couple of you who've done tires and worked at tire shops. Alignment is the biggest eater upper of tires prematurely, I would say, other than like, catastrophic failure. But things that are maintenance concerns, alignment is gonna be a big chewer upper of tires. And those tires aren't cheap. And so if you start getting a fleet with a few units, dozen units, hundreds of units, and they start burning through tires, they're going to want to figure out why pretty quick.
Blown shock absorbers can cause really, really bad cupping on steer tires as well, because they start to bounce. And without that shock dampening the bounce, you get highs and low spots on your tires really bad because it's just bouncing down the highway.
Exactly. Yeah, exactly. And that'll happen with any tire in certain configurations. If you don't have that shock absorption, it's going to flutter and bounce down the road, and yeah, it'll cause tire wear pretty quickly. It's quite amazing how fast you can wear out a tire. If any of you have ever dragged a trailer that has seized brakes won't release, you drag the trailer through the yard, you'd be surprised how quick you can make a flat spot on that tire, or and wear it all the way down to no tread. Right?
One of our truck drivers we just put a brand new set of 12 on him, and he was trying to slide his fifth wheel back, so he kept using the yard, going back and forth and back, probably for 5 minutes, and then we were like, whoa, and drove him into the wash bay and cleaned out his fifth wheel, and he threw it back, but he messed up all 12 of them. They're all gone.
That's a big bill. That's a big.
It was so bad. And he's like one of our most senior drivers too. It was just like, I don't know, we never let him live it down.
Sometimes that's, it just wasn't your day.
$7,000 worth of tires.
Yeah, exactly. Yeah, easily that much. And then to install them and labor too, right? So time as well. He can't leave now. If he was loaded, changing his fifth wheel positioning, ready to go, all of a sudden he can't go now. So.
And just such an easy fix too. Just like wash your frame rails out. Oh my god.
Yeah, it can be an easy fix. I mean, I know at one of the fleets I was at, we had giant lean-to full of tires, and so it was any question, wheels are bad, you just pull, they're already mounted in balance, so you just pull the correct size wheel and wheel out and throw it on, right? The tire was already mounted on the rims and everything. So
yeah, that's sweet.
Yeah, so yeah, easy fix, but still, I mean, who wants to change all of those tires, right? Like,
you got Cal Tire coming, they do all the tire stuff for us.
There you go. That's what most people do nowadays. It's a liability issue also, so Cal Tire is the tire experts, so they can assume responsibility for that. All right, what else does the suspension need to do? So alignment, important. It needs to attach it, and maintain alignment. We also need to support vehicle weight and maintain stability with the weight too. So as we load the vehicle up, it's going to start putting the suspension down. We need to maintain stability while it does that, as well as cushioning loads. So we have two different terms which are important. We have sprung weight and unsprung weight. Anything above the point of attachment is sprung weight. Anything that is on the road is unsprung weight. So essentially, if you think of it like this, when you're driving down the road in this vehicle, if there weren't shock absorbers in it, whatever would be bouncing is sprung weight, and whatever just hits the bumps on the road is unsprung weight, okay? So it's below these points of attachment here is what they're showing. So you have your leaf springs inside of there. This is where it's attached to the frame, attached to the frame, attached to the frame. So anything above these attachments are going to be sprung weight. Anything below them, unsprung weight. So all the things driving on the road, right? You have your wheel, your hub, brakes, axle, brake pots, all the air lines that are going to be hanging down here, really nice and low, all that stuff, unsprung weight. Everything above here, so the weight of the vehicle, the load, the cab, engine, transmission, all of that, sprung weight, held up by the springs, okay? So what happens as this tractor is turning around the corner? We experience with something called lateral force, okay? Side to side. Anybody who's driven around a water truck or a milk truck or a fuel tanker or something that is large and full of liquid?
Inertia?
Yeah, well, the inertia comes from that liquid sloshing around back and forth, right? So if we just pretend that this trailer is a tanker full of liquid, even though it's probably full of powder of some kind or seeds or something, let's just say it's a big tanker like this and it's full of liquid. So as he's going around the corner, that liquid is going to want to flow up something like that, right? And then when he straightens out, it's going to suddenly all slosh over to this side, and you're going to have inertia is going to be causing lateral forces back and forth. So then you'll have one pushing you this way, okay? What they're talking about here is the suspension here needs to stop this tank from wanting to move from side to side on the top, okay? You don't want this side pushing down here and this side lifting up. You do not want that. So that's what we're trying to resist, lateral forces as well, okay? Any side to side motion while we're going around corners. And we need to cushion shock loads because we know that the roads here are wonderful, right? For any of you who are doing that drive every day, it seems like they just fixed the road a few weeks ago and it's already pretty bumpy. Just outside of Claremont there. How do we cushion our shock loads? Well, for us in heavy equipment, there's three main types: leaf springs, rubber cushions, and air springs. Now, I'd be willing to bet almost all of you have seen leaf springs and air springs, but maybe not rubber blocks. Pardon me. Anybody out there want to comment anything? Have you seen?
I've seen them on my bed trucks. I got it on our unit 240. Actually, most of the bed trucks have these big cushions on them, or some really big.
If you are playing with bed trucks, those big winter trucks and stuff like that, they're going to have rubber blocks. There's a few reasons why they have rubber blocks. And if you also work on anything, that's really heavy and has a tendency to go into really crappy environments, it'll be with rubber blocks most likely. Sanding trucks typically have them, plow trucks. So
You'd
will have.
be surprised how long they last too. Like, I don't think we've ever changed the ones in our bed truck, unless they're cracked.
They're really tough. There's a reason they use them. They last a long time. Yeah, they work. So
Also, I don't know. I just missed the last minute or so. I just went and grabbed a coffee. But what would the shocks be in this section?
Oh, they're going to be. We haven't gotten there yet.
I'm just surprised that, like,
we've talked about shock absorption a little bit, but don't worry, you haven't missed too much.
Yeah, this shock here. I just thought if there's three categories, the shocks would be in that group too.
Oh, we get there in about 4 or 5 pages, so don't worry. And so just to remind you, all of these recordings, and now that the sound is better, they'll be much more tolerable to listen to. But all of these recordings will be posted either on YouTube or D2L somehow. So if you do feel you missed anything, you can go back and look at it as well. So yes, so I think that what you might be, the misconception is shock absorbers don't absorb shock loads. They don't cushion the shock loads like this. It's the job of the leaf spring. Okay, so that might be a misconception because of it's called a shock absorber.
Yeah, that's what I'm talking about.
Yeah, it's not actually absorbing the shock from the road. Okay, it's dampening something else, and we'll talk about that. For instance, do you see on this rubber block here, do you see shock absorbers?
No.
And do your bed trucks have shock absorbers?
I don't think so. I actually I can't. I haven't really now. I can't remember. I feel like they do, but
Your axle, they probably do, but most likely on these rubber blocks, they wouldn't. Because the steer axle, I'd imagine, is a leaf spring.
oh yeah. I'm thinking about the back when you're asking. I'm trying to remember if there is or not.
Yeah, I would imagine there probably isn't. So if you see actually on this leaf spring even as well, there is no shock absorber because this particular one is a very heavy duty leaf spring assembly. Okay. This one, this leaf spring and this rubber cushion, these are from quite heavy tractors that haul quite a bit of weight. Okay. This air spring suspension here, if you work on things that are hauling groceries to and from Safeway or from pickup and delivery or sort of everyday kind of tractors that can hook on to any kind of van and haul it around, they're going to have this air spring. This is made for the highway cruisers, right? Driving hundreds and thousands of kilometers. That's what these air springs are for. These two are what we're going to see up here if you're working in any kind of industry, agriculture, oil field, all that. Very heavy suspension. And that's what these two are. And they don't have shock absorbers on them. And we'll talk about why that is and what shock absorbers do. So does that answer your question?
Oh yeah.
What else does the suspension need to do? So we need to maintain contact between the tires and the road. So here's where we're going to start talking about these springs a little bit. And this applies to any one of these. These rubber blocks act as a spring. These airbags act as springs. That's why we call them air springs as well. And the leaf springs obviously act like a spring. And here's what the spring is doing. So as the vehicle is driving, we are going to have a depression or a bump in the road. Okay, you can see here that it's driving forward and we have a bump in the road. So what happens is because the spring, whatever it is, whether it's air, leaf, or rubber block, is designed to flex, it's going to compress before the vehicle frame moves. Okay, we've all seen the commercials of vehicles driving and the tires are going up and down very rapidly while the whole body of the car is staying still, right? That's what is happening right here. And this is just a snapshot as the wheel rolls over that bump. Spring compresses and now it has energy inside of it, okay? If you go over the bump and the vehicle is allowed to keep moving forward, the energy will be released and the spring will expand again. Same thing happens with the airbag. In this position, so here on the stop position, your airbag might look like this, nice and inflated. Okay. Here in your jounce position, it'll start bulging out. And then once it releases again, it'll look just like the first picture again. Okay, and the same thing happens with your rubber block, just to a much lesser extent. You can't see it as much, but you can still see them flexing. They do compress and absorb energy in much the same way. What also happens now, let's say you go up this bump, but the bump continues on. I'm going to erase some more of this here. The bump continues on. So you just essentially you drive up on a curb or something. Instead of the energy releasing down like that, eventually what would happen is the frame will lift up, okay? And it will lift the vehicle back up into this position moving forward here, okay? So this is always going to be once the energy is released. It does not hold on to it forever. It doesn't just store it and wait for an opportune time. It will release it very quickly after it has been absorbed.
That might be the difference between shocks right there, because I don't think shocks push your vehicle back up.
No, they won't necessarily. Depends on the shock. Some do expand, continue.
Oh yeah, you're probably right.
But we'll get there. Yeah, we'll talk about shocks and what they're specifically for. Right here is where we'll talk about shock absorbers. So now the last objective, the operating principles of common suspension systems. So now we're going to talk about how suspensions work. So one of the things we need to do in a suspension, remember I said it maintains alignment, road stability, lateral stability, attaches everything. So we need a way to limit the movements. So the way that we stop the amount of movement that a suspension has is with different axle stops, torque rods, bushings in the suspension components, and then shock absorbers as well. So an axle stop is just going to limit how much up and down movement a vehicle has. A lot of times if you have an air suspension, it will deflate and sit on the axle stops. Sometimes in the airbag, there'll be an internal axle stop that when you deflate the airbags, that's what the suspension will rest on. In this instance here, you can see as we have lateral forces being applied because the vehicle frame is rolling here, we have a limiting device right there in the corner. That's going to stop how far the axle can move. If it goes beyond this, the frame itself will begin to twist. And that's just because of the solid contact in between them. We have two different types of torque rods, okay? So we use torque rods to stabilize against forces created during operation. So there's acceleration and braking forces. They tend to twist the axle housing in their mounts. And then we have longitudinal ones as well. They connect upper portion of the axles to the cross members. So longitudinal ones go along the frame, okay? So this one, a longitudinal torque rod, is what's going to absorb braking and acceleration forces. So this is a drive axle here. When this drive axle wants to start going forward, what happens is the wheel on the road turns and pushes the axle forward. But now the axle is attached to the frame through the suspension. So through this longitudinal torque rod, it's going to push the frame forward, okay? As you start going around a corner with the steer axle way up here, right? So the steer axle is steering off into a direction, some way over there. As you have that, you're gonna have one side is gonna wanna pull on the axle and the other side is gonna be pushing on the axle, okay? Because it's trying to fight that turning from the steer axles, and those longitudinal torque rods are what's going to absorb that. In that picture above where we talked about the axle stops as well, that's what transverse torque rods are for. This torque rod right here that's going to be attached to the bottom of the drive axle housing and then to the side of the frame right there, that's what's going to be trying to fight this movement here. So you can see this actually is where that mount would be, and you would have the torque rod right here. Okay, this would be trying to stop this rotational movement like that. What do all of these things have inside of them is rubber bushings. So just like the rubber blocks, sorry, has someone got a question?
What do you call the B-type rod? Is that a transverse rod or longitudinal torque rod?
What do I call the what, sorry?
The B-type one? The B-type torque rod?
The V-type on a Kenworth there, on a
Yeah.
Kenworth suspension, those things are garbage.
So on a Kenworth, the V-type, you're talking about the 8-bag suspension, and it has rods that are like this and like this and this, and like this, or and like
no, it's just one wishbone that just goes over the top and then to the front, so it pushes it forward. Yeah.
Okay, so it'd be on the front, like this.
Yeah, just like you had it right there.
Right there.
Yeah, oh yeah, you bet. Yeah, so it pushes forward on them.
Yeah, and then this.
And they don't last long at all. We've had to try a bunch of different things, putting more plates for where they attach and stuff like that, but they don't last very long at all. Like I've changed 3 or 4 in 1 year with one truck.
Just a different.
The other one's
Right.
What's that?
Oh, sorry. Please finish.
Yeah, and then so like we have an old 601 has the traditional torque arms, so it's got those tapered ends on them, the one forward and one back, and those ones have lasted us. I don't know, we change them every 5 years almost. And then those B ones, it seems like you change them every month.
And it's just engineers. I mean, Kenworth likes to try new things. A few other companies do. They're always trying to get new ideas, right? And that was just.
I think highway haulers love them, but if you're doing a lot of off-road stuff, not so much.
You'd be surprised how a lot of units are mis-spec'd for what they're doing, right? Like you buy a lot of equipment at auction. Someone had a tractor that they bought to haul milk with. So they hauled one tanker that had milk. They never really went in anywhere mountainous, so they didn't get a transmission with a whole lot of different speed or gear selection variations. Now suddenly you take that thing with the Super B hauling through the mountains and it's a nightmare, right? But if it were spec'd properly with the right suspension and transmission, maybe a different even engine with a different power band or a different setup on your engine, it would make a world of difference, right? So you're absolutely right. In some instances it'll last, some not. These, this is going to be, so to answer your question, what would you call these? I would call these a Kenworth specific, whatever Kenworth calls them.
And they call them B-rods.
What they're designed to do is essentially, instead of having a one lengthwise and one sideways, they just tried to combine them. Good idea. Did it work? Not all the time. Depends on where they are, right? So does that answer your question about the system?
Yeah, thanks.
Yeah. There's actually a, so probably because all of you are first years or in this program, I say all of you, but I know it's not true. It's not all of you. Probably a large portion of you have seen the suspension Hendrickson pivot bushings. Okay? I'll draw a little picture here. So you've probably seen, it looks like a beam with a big hole in it like this. And then the beam comes down. And then there's going to be a pedestal right here where
Trifunctional bushings
goes on. Yes, hey, someone knows the full name, trifunctional bushings. So why do you think they're called trifunctional bushings?
They have 3 jobs to do.
Hey, and so you've actually learned all the jobs, right? So the bushing is right in here. So, and the frame, I'm going to move my drawing here. Your frame would be up here, right? Attaches through a hanger here. So first job they have is forwards and backwards, right? They go forwards and backwards. Axle either is a driving axle, or if it's on a trailer, it gets dragged by the frame, okay? So either way, that bushing goes forward and backwards. Second job they have is to make it hold side to side, okay? Side to side, just like transverse torque rods and longitudinal ones. So far, 2 jobs. The last job it has is to limit the amount of rotation this way, okay? So 3 jobs that it has, and we've actually only talked about 2 of them.
And it's also pretty, when you're setting them up, it also has a lot to do with alignment too, because you can put your tires quite out if you don't set them up right.
Mm-hmm. So you're absolutely right.
The twisting plate.
The alignment is in here. You can adjust alignment. What they're taught, the reason they call them trifunctional bushings is because the bushing itself has these 3 jobs. With this suspension, you're absolutely right though, whoever said that, in the mounting for the bushing is where you can adjust your suspension alignment. You're absolutely correct. And so yeah, job of the rubber bushings, they allow flex, but then return to original position. one thing we'll talk about with these bushings, there's actually an orientation that you need to maintain when you're installing them. So the bushings are shaped a specific way where there is a specific line that needs to be completely vertical, all right? And we'll talk about that too. So if you've seen trifunctional bushings before, this is sort of what they look like. My bad drawing of them here. This is almost what it's like, okay? There's a couple gaps in here and in here, and then there's lines here. These lines are supposed to tell you where the horizontal of the normal ride height would be, and you install it based on that. And that's just the way they're designed. So you can see as you're going around a corner, axles are going to want to shift sideways. The vehicle is going to want to try and roll. Rubber bushings through the metal bonded mounting is typically how you're going to absorb this. This allows flex, but it returns to its original position is what the rubber will do. It's like a rubber band. Stretches out. When you let it go, it'll go back to its original shape. Shock absorbers. So let's talk about what do shock absorbers do. So resistance to road impacts and wheel hop, which gives a firm, stable ride. So they're not designed to absorb the force. What they're designed to do is slow the absorption of the force, if that makes sense. So that it doesn't happen so rapidly. They're also designed to release that force in a controlled manner, okay? That's how you get that firm, stable feeling of a ride. They're gonna slower the transfer of weight from one axle to another during acceleration and braking. It's the same process. They're just slowing the rate at which your suspension is going to absorb and release energy. If you just have a spring, who knows the old door stoppers? I have one in here, right? Bring it. It was a big spring, okay? Really big coil spring with a little knob at the end of it. And if you kick it, it would go and really fast, vibrate and make a noise. It's because it was just the spring, and when you bent it, you absorbed energy. When you let it go, it released that energy really rapidly, okay? If you would have had a shock absorber in there, you would have still been able to bend it, but when you released it, because the shock absorber had oil trying to push through, or gas in some cases, it would have moved, but it would have been at a controlled rate. So it wouldn't have been that really fast. It would have been a nice, steady release, okay? And that's what a shock absorber essentially is designed to do. How does it do it? Through oil, typically through oil, okay? One of the most common failures on trailer shocks is leaking oil, or what we think is a leaking shock absorber. There are shock absorbers, and specifically what I think about is Peterbilt shock absorbers that are gas filled, okay? And if you've ever taken a bottom shock bolt off and the shock absorber suddenly went thunk and expanded as far as it could, then you have a gas-filled shock, okay? And so those ones always want to spread apart. They're always trying to spread apart. So in that case, they would help lift the vehicle back up, but it's not going to really, it's not necessarily what their function is, not like the suspension, okay?
Do those gas shocks still have oil in them?
As far as I know, they don't. Those
Like when you take they come with a band on them, so that and then so you can hook up at least one side, and then once you cut the band off, then they expand. They're annoying to put in, but they work pretty good.
So you haven't talked about hydraulics yet. The thing about a hydraulic shock is it would be difficult for you to absorb and store the energy like that, like what we're talking about, okay? What is easier to do is to have a gas shock like that. And that's because the incompressibility of liquid, okay? The way a hydraulic shock works is you're forcing the liquid through small holes. That's what this picture is that I'm showing you right now. I don't go into really big in-depth into what's happening in what state, what orifice it's going through, because that's a lot of stuff to not, like, you don't really need to memorize this, okay? You just need to know that when a shock, oil-filled shock, is being compressed or expanded, it's trying to force oil through a certain sized orifice against a check valve. And that's how it limits and how it's slower and to expand and contract, okay? That's how it limits the movement. A gas shock is essentially like compressing a balloon and then letting it go back to its size, okay? Gas can be compressed, but a liquid can't. And so it's different design, and that's how they do that. That's why the one would expand all the way and an oil one won't. An oil one, we would just pull it to where it is, and then that's where it is. To say you couldn't have some sort of accumulator in the shock, an oil shock, to add some of that, yes. It's just not typical in our application where we see it in heavy duty. So it is 5 to 12. And we have a little bit left in this book still, about halfway. We're going to start talking about how the different types of suspensions operate. But I think I'd like to start that after lunch. So it's 5 to noon right now. So let's meet up again at 5 to 1 type of thing. So in an hour, and then we'll start again at about